Hello students, I'm glad to meet you all in this video. So in today's video, our students are going to discuss a case study in smart grid. So they have taken a case study regarding a smart grid which is being implemented in a country, and now they are going to discuss about what are the challenges and how they came up with the solutions. So let's get into the topic.
So after the 2011 earthquake and a tsunami, Tokyo to build a more resilient energy infrastructure, the smart grid become a key element in ensuring energy stability during a disaster. Let's look the challenges faced and how the city overcome them. Grid vulnerability to natural disaster. Japan's energy infrastructure was vulnerable to earthquake, which could cause a large-scale demand fluctuation. Energy demand skipped during their natural disaster.
Limited disaster preparedness. Critical infrastructure such as hospital lack backup power during the outages. What it says is that when the infrastructure is gone due to the tsunami and earthquakes, the main infrastructure such as hospitals or main things such as schools, everything lacked in power sources in the outages. Now the solutions will be set by Apurva.
Now I am going to say the solutions: microgrids and decentralization. Tokyo integrated the microgrids, which allows the neighborhood to contact easily throughout them, and the critical infrastructure like hospitals to operate independently in the event of a grid failure in case of tsunami or an earthquake. Automated fault detection and recovery. As the smart grid has a resilient capacity, it is called as self-healing capacity. So it automatically fault the detection and it automated fault detection and recovery. As the smart grid has a resilient capacity, it is called as self-healing capacity. It automatically detects the fault and it recovers self-healingly. As the grid was equipped with advanced sensors and automation to detect the faults and quickly restore the power in case of earthquakes. Renewable energy integration. Microgrids are connected in each other so that renewable energy integration can be done easily with this. Solar energy, wind energy system and the demand response program help the balanced grid and ensure the reliable energy supply.
Now, as the conclusion, the Tokyo smart grid is a prime grid which shows us which is an example of how the smart grid can be resilient in the time of calamities such as tsunamis and earthquakes. It can be done by decentralizing the power generation and also integrating renewables and implementing them in the automation.
So in this case study video, we have discussed about the Tokyo smart grid, which possesses high resilient capacity. So which is the key feature for a smart grid. So in this video, we have discussed about how a smart grid with resilient character has restored the city after a big disaster. So hope this video is very useful to you. I hope our students have discussed the case study in detail so as to make you understand about the resilient feature of a smart grid. So thank you everyone and thanks for joining this video.
So in this case study video, we have discussed about the Tokyo smart grid. So this is the actual layout of the Tokyo smart grid, wherein which a couple of renewable energy sources along with the conventional power energy sources has been integrated through a smart grid, and we could see a lot of microgrids which has been connected to the group of localized renewable energy sources along with customers, and we could see a lot of primary substations and ultra high voltage substations then and there where they could easily transfer power. So these number of substations and microgrids has been established in order to ensure the resilience capacity of the smart grid. So due to the major disasters that often occurs in Tokyo, they took a plan to construct more microgrids so that any problem in any one grid can be overcome by the other group of microgrids. So this is the overall layout of the Tokyo smart grid. So I hope this case study video have given a clear idea about how a resilient feature is very much mandatory for a smart grid through this Tokyo Smart Grid. So hope this video is very much useful. We will meet in the next video. Thank you.